Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. On this video, guys, I'll be tackling the sixth question from the May-June 2024 Physical Science Paper 1. Please do expect a total number of 10 videos because the question paper has 10 questions. Nah? Each and every question, each and every question will have its own video. And please, guys, do take this very seriously because I strongly believe that knowing how to tackle exam questions will give you an edge whenever you write your final exam. So please do share the video to your peers so that they may have the same edge as you. Okay, a stationary listener records the frequency of sound emitted by the siren of a police car. When the car, which is traveling at a constant velocity, approaches the listener, the recorded frequency is 615 hertz. Okay, and then we are told that the car passes the listener at time t1 and then moves away from the listener, and then the recorded frequency is now 526 hertz. Okay, by just reading this statement, I already know that since they never told me that the speed of sound is equal to this, that means I do not know the speed of sound, and I was never told the frequency emitted by the source. So there are two unknowns over here. I know that my listener is stationary, so the velocity of the listener is equal to 0 meters per second. Okay, I strongly believe that since there are two unknowns, I will have to solve simultaneously. Okay, let's continue. We are told to effect the effect of wind. They want us to state the Doppler effect in words. Doppler effect is the apparent change in the observed frequency of the source as a result of the relative motion between the source and the listener. There is the apparent change in the observed frequency of the source as a result of relative motion between the source and the listener. Okay, and then now we must use the information given to calculate the speed of sound in air. Our Doppler effect equation simply says FL is equal to V plus or minus VL all over V plus or minus Vs multiplied by Fs. Né? But over here, guys, we are given the frequency detected whenever the source was moving towards a stationary listener and when the source was moving away from a stationary listener. Are you together? So since the source was moving towards, that means the equation here will simply be V. FL is equal to V rather all over V minus Vs. Excuse me. All this is multiplied by the frequency of the source. Né? Remember that, guys, the velocity of the listener is 0 meters per second since the listener was stationary. That's why on my numerator I'll simply have UV. Are you together? And whenever whenever, guys, the source is moving towards the stationary listener, you will always have a minus at the bottom. Are you together? And then now I have FL being equal to V. At the bottom I have V plus Vs. Whenever the source is moving away from the stationary listener, at the bottom we'll simply use a plus over there. Then all I have to do now is to just substitute. Remember that, guys, I was told that the frequency whenever the source was approaching the stationary listener, it was 615 hertz. I have V over there, V minus 26 multiplied by the frequency of the source. Né? All I can do here is to just cross multiply. I'll have 615 multiplied by V minus 26 is equal to V multiplied by Vs. And then I can just remove the brackets. I'll have 615 V multiplied by 615 multiplied by 26 This will give me 15,990 is equal to V multiplied by Fs. So this will basically be the first equation. Okay, and then I know that whenever the source is moving away from my stationary listener, the frequency detected was just 526 Hertz. Still a V and V plus 26 multiplied by Fs. All I have to do now is to just cross multiply. I'll have 526 multiplied by V plus 26 is equal to V multiplied by Fs. So I'll have 526 V plus 526 times 26. This will give me 13,676 is equal to V multiplied by Fs. Ne? And that will simply be the second equation. So the first equation is equal to the product of V and Fs, and the second equation is also equal to the product of V and Fs. So I can simply conclude that equation 1 is equal to equation 2 all together. And then this will give me 615 V minus 15990 is equal to 526 V plus 13676. Okay, and then this will give me 615 V minus 526 V is equal to 13,676 plus 15,990. So on the left hand side, I'll have 615 minus 526. This will basically give me 89 V. And then on the other side, I have 13,676 plus 15,990. This will simply give me 29,666. If I divide both sides by 89, this will simply give me the speed of sound to be equal to 333.33 meters per second. Now I do know the speed of sound in air. I know the speed of sound in air. So the speed of sound is basically 333.33 meters per second. Now I'm supposed to calculate the wavelength of the sound emitted by the police siren. For me guys to be able to answer this question, I must know the frequency emitted by the source altogether. Or I can say I must know the frequency emitted by the siren. Why do I need to know the frequency emitted by the siren? Because for me to find the wavelength, I'll use the formula that says the speed of sound is equal to the frequency of the source multiplied by the wavelength of the source, and hence the wavelength will be equal to the frequency, or rather the wavelength will be equal to the velocity of sound, or the speed of sound divided by the frequency. So if I know the frequency, I can simply calculate the wavelength. I can use either one of these equations to find the frequency. Let's just continue with equation 1. I can divide both sides by V, and then I'll end up having 615 V minus 15,990 all over V is equal to the frequency of the source. All I have to do is to just substitute. 615 multiplied by 33.33 minus 515,990 all over 333.33. This will simply give me the frequency of the source. 615 multiplied by 333.33 minus 15,990 all over 333.33. So this will basically give me the frequency of the source to be equal to 567.03 hertz. 567.03 hertz, right? So the wavelength is basically equal to 333.33 all over 567.03. 333.33 divided by 567.03. This will give me the wavelength of 0.5878, basically 0.59 meters. So my wavelength, guys, is just 0.59 meters. 0.59 meters. Ne? For you guys to know wavelength, you must know the speed of sound, number one, and the frequency. So initially, we did not know those things. Are you together? But we solved simultaneously to find them. After finding the speed of sound in the previous question, we went and found the frequency over there, and then the quotient between the speed of sound and the frequency will give us a wavelength. And then I'm supposed to sketch the graph of recorded frequency versus time for the motion of the car as it moves towards the listener, passes the listener, and then moves away from the listener. Label the time t1 on the graph. No values need to be indicated on the frequency axis. Okay, so our graph, guys, will simply be like this now. Since initially the car was moving towards the stationary listener, it simply means that the detected frequency will be high. Are you together? And then over here at time t1 there was a change in frequency, and then the frequency was now 526 when the car was moving away. So over there I simply have time t1. This is time measured in seconds, and then over there I'll simply have the observed frequency. Which is measured in hertz. Writing down the values, guys, is not necessary, né? But over here you were supposed to write 615 hertz, and then over there that's 526 hertz. That's how, guys, you're supposed to draw your graph. Yeah, so just stay tuned, guys, and wait for more videos. Thank you very much.